I'm Greg Hrutkay of Hrutkay Mods, and in this video, I'm going to be upgrading this iMac G4 to an MC7448 CPU running at potentially 2 gigahertz.
Collin, what are you doing?
I'm just making my own video. What are you talking about?
Well, this is my video.
Well, I'm upgrading the iMac, aren't I?
That's a good point, yeah. All right,
Just kidding.
you. Yeah, well, that's Collin Mistr, guys. Yeah, today we're working on the world's fastest iMac G4 once again. This time we're going to actually make it work, hopefully. What do you think, Collin?
I think we'll get it going.
You think so?
Oh, yeah.
Well, welcome to episode, 16 of season 4 of the PowerPC Series and part 500 of the world's fastest iMac G4. This is going to be a fun time, guys, and let's get to it.
Alright, so to begin the process of upgrading the CPU in this machine to a 7448, of course the first thing we need to do, as with any unsupported CPU upgrade such as this, is we need to apply a firmware patch to the system's ROM in order for it to boot with the new CPU installed. So of course this needs to be done either before you upgrade the CPU, or otherwise it won't boot, or it is possible to do it externally via an EEPROM programmer if necessary. So in order to do it for this machine, I'm going to be using the GigaDesign's firmware patch, and of course this is designed for CPU upgrade cards used in various Power Macintosh G4 systems. So in order to apply the update, the procedure is very simple. You simply open the application, you select Install Firmware Update from here, and then just click Shut Down. So once the machine has fully shut down, you'll need to boot it into system programming mode, and in order to do that on an iMac G4, you simply hold down the power button until it beeps.
Yeah, you gotta remember which side the button's on there, Collin.
I know. Alright, and as you can see there, it says Install Firmware Update was successful, so that means the firmware patch was successfully applied. So with that, I'll go ahead and let the machine reboot, and then we can begin the process of setting the CPU vCore voltage to support the new CPU, which of course is a 7448.
Sweet. Okay, guys, so you guys just watched him do the flash there. Now, real quick, this is not the original world's fastest iMac G4 that we started with. This is actually a part system I bought for the 5th or 6th board, it seems like. How many boards have we gone through?
I think 4.
Fourth board. This was a part system. We were going to tear it down and do my 17-inch. Well, I bought this thing as a 17-inch. Parts not working, all that stuff. And it turned out to be a 20-inch when he unboxed it after it sat here for a year. And it was fully functional other than not having a hard drive. So we got a 20-inch extremely cheap. I think I paid less than $100 for this thing. And this is the perfect place to actually build the world's fastest iMac G4, and hopefully we're successful at it. Now, guys, we're going to tear this thing down, and the next time you see it, it will be on Collin's bench being worked on. So let's get to it.
Alright, so the first step, like I mentioned, is we need to set CPU vCore voltage. Now, according to the schematic, this board should be currently set to 1.57 volts, which of course is appropriate for the 1.25 gigahertz MC7445 CPU that's on it. But for the 7448, you can go no higher than 1.4 volts without frying it, so we have to decrease that voltage before we put the CPU on. And of course I will be testing it with the CPU installed so we can power it on and measure the voltage just to be 100% certain. Now, in order to change the CPU vCore voltage on these boards, there is a resistor right here, R388, which you change the value of accordingly for the desired CPU vCore voltage. And according to the schematic, the relationship is the higher the resistance, the higher the voltage, which is interesting, but I guess that's the way the controller chip works for that circuit. So right now the resistor is at about 470 some k ohms, and I'll be replacing it with a 200k ohm resistor. So of course, first thing we need to do is apply some flux, just like so, and then we can turn on the hot air and simply remove and replace it.
Yeah, let's just test it with our hand. See how hot it is getting, so you can burn a hole through it. Yeah.
Yes.
Yeah.
Alright, so the old resistor is off, and this is the 200k ohm resistor, which was soldered on. Alright, and it's simple as that. Our new resistor is soldered on, so we're going to go ahead and put the heatsink back on, plug the board in, and test it, and check our voltage and change the value accordingly.
Cool. Yeah, Apple could have definitely made that a lot easier to test.
Yes, testing is such a pain. Also has no RAM in it, so it won't post.
But it will turn on.
Yes.
Oh yeah.
.1 volts, so that is too
Low?
low of a resistance.
Yeah.
So I'm gonna estimate, we'll start at like 300k and then go from there, see where we're at.
There, because there's no set resistor value that you know of, no charts or anything. You just have to guess.
I'm literally just guessing. There's probably a way to calculate it, but I haven't taken the time to figure out exactly how to do that.
Yeah, there's not many people wanting to build really fast iMac G4s these days, so.
Yes. Exactly.
Yeah. So he's going to change this resistor again and try to figure out everything to make that work. So he's going to do it off camera because there's no point in filming it. It's the same process.
Trial and error.
Trial and error, exactly.
Alright, so I've replaced the resistor with a 315k ohm resistor this time, and that puts the CPU V-core voltage right at 1.35 volts, which is perfect for the 7448. Its maximum rating is 1.4 volts, and its recommended rating is 1.3. So if we're going to be overclocking it slightly, 1.35 should be within the realm of what we want. So I'm going to go ahead and turn it on, and got the multimeter right here, and show you exactly what we've got. There's no RAM installed, but as you can see on the multimeter, we're reading 1.356 or 1.357 volts, which is perfect. So now that we've done that, next step, of course, is to start soldering the new CPU on.
Awesome.
Before we get started here, we've got a few options of chips to use here. So these, of course, are 7457s, and which we can't use. But these green ones, of course, are the very sought-after 7448.
You know, I should have brought my 800 megahertz iMac 17-inch. That would have been fine with the 5.7s.
Oh, yeah.
Oh, yeah. Yeah.
And L3 cache upgrade, too.
Ooh, yeah. That'd be nice.
But anyway, we have to find one that we think is good. These are from China, and they're not the best quality. They are used. And I have had some of these that have cracks in them and don't work. So,
Well, that's lovely.
you want to look through these and find one. Oh, and then for some reason they started reballing them with lead-free solder, and that makes it even more of a pain. Let's see if I can find one that's leaded. So you can see,
And
so
they're
you can see the
shinier.
difference.
Yeah.
You can see the difference here between leaded, this one, the shinier balls, and lead-free.
Yeah, you really can't tell on camera, but yeah.
This one's lead-free.
They're definitely
and
shinier.
This one's the leaded solder, and then this one is
Yeah.
the lead-free. You can see it's a lot duller. And the melting point of lead-free solder, of course, is much higher than that of leaded solder. And these CPUs don't like much heat, so that poses a bit of a problem sometimes. In fact, sometimes I've even reballed these straight out of the box just to get rid of it. But we've got this one with leaded solder already on it, And here's what it looks like. So you can see it's got a chunk out of it right there, so maybe we won't be using that one.
Well, it might be fine.
And the die is what you really want to look at, and it's got corners chipped, which all of these do, but it looks okay. And we can always replace it if it doesn't work. So no big deal. Alright, so the hot air is still warming up, or I mean the board preheater. But once that gets warmed up, we can go ahead and desolder the original CPU. And since these boards all have leaded solder already on them, soldering is very easy on these. It doesn't take very long.
Well, that's good.
We'll go ahead and zoom in a little bit here.
Yeah, that's why I have it lined up perfectly.
Yes. Okay. And just edit out all the waiting, because it's boring. That's what I always do.
Yeah, it can be.
Getting some good heat in her now.
So it's kind of like a giant skillet.
Yes.
Yeah.
Except, of course, you have to keep the board elevated off of it, because
Otherwise, it will melt everything.
yes,
Yeah. What is that, 146C?
150 some is what I set it to, so it's pretty much ready to go now.
Yeah, it's ready.
All right, so step one is removing this plastic piece, because if you don't, it melts and smells awful.
Fun.
So go ahead and just pull that off, and it's really easy once it gets hot because it melts the adhesive. Now this foam stuff is really hard to get off, and I found that it doesn't cause any problem just to leave it on there. So it will stay on there for the soldering process. So next up, like always, we just have to apply some flux to the perimeter of the chip. And with that, we can just go ahead and set the hot air nozzle over top of the chip. Make sure it's well in line there. And then we'll go ahead and start removing it, or heating it, and then remove the chip. So we've got the upper hot air temperature set to 280 degrees Celsius, and the bottom temperature set to around 150 degrees Celsius. And for a leaded solder board like this, that should be perfectly fine. So the soldering process does take a little bit of time, so we're just going to wait for the balls to melt, and then we can remove the chip. Alright, the chip is now melted, and I just check it every now and again with a pair of tweezers, just poke at it a little bit and see when it moves. So now we can go ahead and remove the hot air and remove the chip.
But we definitely make that look easy.
And that's it. So now what we need to do is just clean all of the residual solder off these solder pads, and then from there we'll be ready to install the new chip.
Awesome.
Alright, so now that we've gotten the chip off, of course we need to clean the residual solder off the pads. So in order to do that, we just use the soldering iron, some fresh solder, and then from there we'll use some solder wick.
So where's the world famous optical drive you used to solder on?
It's right down there. In fact, right there.
Oh, I see it, yeah.
I still use it.
We make this thing stable enough. This is going to be my daily user for a week or so.
Oh, that's sweet. We're gonna get this thing stable.
I hope.
I estimate around 1.8 to 2 gigahertz should do us. I've never been able to get a 7448 Jordan perfectly stable at 2 gigahertz. So,
But I'm hoping for at least 2. Preferably more, but yeah.
the main problem is these Chinese 7448s are not really the best.
Mm-hmm.
And I've tried and tried and tried to get better ones, and I just can't for a reasonable price, at least. Alrighty, so the board has now had all the residual solder removed from the pads. So now, you just have to clean the old flux off using some rubbing alcohol and a paper towel. There we go. Looks perfect. So
you
that's
can
exactly what you want to see. And now we'll go ahead and prepare the new chip to be installed by applying some flux to it.
Cool.
And then we'll be able to solder it on. Alright, so now that we've gotten our target CPU determined, this is a 1.7 gigahertz rated 7448. We're going to go ahead and apply some flux to it and heat it with this just to make it flow better on the chip. And then from there, we'll be ready to solder it onto the board.
Awesome.
Alright, and now that the chip is prepared, as you can see there's an even coat of flux all on it. We can go ahead and align it to the board after applying some flux to that as well. Alright, so now that we've gotten the CPU ready, we'll just apply a little bit of flux to the board itself. Just a very small amount here. And once that's applied, I'll just go ahead and wipe a little bit, just to ensure it's a very thin layer. And then we'll take our chip, align the pin 1 mark with the white silkscreen piece there. Just like so. And then of course we have to go and fine align it to get it exactly aligned with the silkscreen outline. Alright, so that is pretty well aligned there. So now we're ready to align the hot air over top the chip once again and solder it on. Alright, so the chip is soldered on successfully. I've just been watching it using a flashlight to look underneath the chip, and you can pretty obviously see when the balls melt and then the chip drops a little bit closer to the board. So that looks perfect to me. So go ahead and turn off the hot air. It's already cooling down now. And then once the board cools down, we'll be able to install it in the machine and test it to see if it posts. Hot for me though. I'll let it cool a little bit more.
Yeah, just let it rest on the crown there.
It's not going to melt.
Yeah, it's true. It's pretty cool. And the old chip.
It's right there.
It's the old chip, which is literally half the size, well, twice the size of that one, die-wise. It's pretty impressive.
Yeah. Alright, so we got the board put in the machine. I had to modify the heatsink slightly. You actually have to bend these ends up because the 7448A is much thinner than the 7445, and the solder balls are much smaller because you can't get the 0.89 millimeter ones anywhere. So I've got that in, modified properly. It's making full contact. So we'll go ahead and power it on and see if it posts.
It's a good sign.
All right, chime, that's good. So we'll take a look at the screen, which is kind of a pain.
Yeah, it's an understatement. Yeah, flashing folder.
Good. All right, so the machine boots and runs as intended.
Cool.
So now the last step of this process is to overclock the CPU to the target clock speed. So in this case, our goal is going to be 2 gigahertz. So hopefully we can get there. If not, we'll just downclock it from there to 1.9 and then about 1.8. These tend to like, based on my experience, about 1.8 to 1.9 gigahertz. They don't really work well at 2 gigahertz, but that all depends on the specific chip. So chances are it's probably not going to run at 2 gigahertz, but there is a chance it will.
Goal is 2 gigahertz.
Yes.
Yeah.
So we're going to start there, and if it runs stable at 2 gigahertz, we're done. But if not, then we have to modify it further.
Cool.
So, cool. Back out it comes. All right, so now that we've verified that the board is functioning as intended, Now we can go ahead and set the PLL configuration to our desired value. So, of course, our goal here is to get the CPU running at 2 gigahertz. So we're just going to start straight from there. And in order to do that, all you have to do is set these PLL configuration resistors accordingly. In the case of this machine, we'll need to set it to a 12 times bus multiplier, which, of course, 167 megahertz bus speed times 12 will give you a clock speed of 2 gigahertz. So let's go ahead and get the hot air turned on, and I'll go ahead and set these resistors accordingly. First, apply some flux to the resistor pads here, and we can set it accordingly. Now, according to the schematic, these values should be 1, 1, 0, 1, 1. So high, high, low, high, high. So we'll go ahead and just set that accordingly right now.
This is where I usually get it backwards and flip everything around. So it's like low, low, high, high, or yeah.
Well, to make it more confusing, some boards, the low position
Is different than the other one.
Resistor removed is actually high, and resistor placed is actually low.
Yeah.
Because they're just pulled up. But luckily on the iMac board, it's pretty simple. There's 2 separate resistor pads for high and low. So we won't be confused with that in this instance. So the EXT pin, R382 or R383, should be set to low. So I think low is that side. Let me verify here. Yeah, max bus sleep is so high is this side and low is that side, so set it accordingly here. So EXT, R382 or R383 needs to be set to 1, I believe. Just verify that one more time. Yeah, EXT needs to be set to 1. So that means we will set it to R382 if it isn't already set there. And it is not, so we'll go ahead and set that. We can also verify that by checking the config for 1.25 gigahertz, and sure enough, it's not set, so we will reverse that.
You think if Apple was going to sell a system that only came with 1 speed, they would have kept you from being able to overclock it in the first place by like hard wiring the jumpers into the board.
That is true. But luckily, according to the design specification, resistors are required at specific values. There we go, that one's set. Next should be a 1 on CFG 0. Let's see, CFG 0 should be... Which one is CFG 0? It should be R381 and 379. So the one right above it. Good. And that needs to be high as well. So we'll move that one. We'll clean it more later, but for now, it's good for testing. So we'll go ahead and put the board back in the machine and test it. And if it boots, we will stability test it and make sure it's all stable. And hopefully it will be. So go ahead and reassemble it.
Cool. So we're just testing it by putting it back together right now.
Yes. So right now I'm just going to make sure it still posts.
So it's not the final assembly right
No.
now. Okay.
I want to make sure it still posts. And then I'm going to put the bottom cover back on for the drives in and everything so we can boot it and run like Geekbench or something on there to make sure it's stable.
Gotcha.
Alright, at 2 gigahertz.
It's a good sign.
That's a very good sign. Now, if it's not stable, it usually doesn't show a display. Oh boy.
Yeah, it's got a display.
We might have the world's fastest iMac G4 in our hands. Because in the past, when I've done this, and it's really angry, it won't post.
Well, if anything, you might be able to up the voltage a little slight bit more if it isn't stable enough.
Resistors to use to do that. I think I do, though. I got so many because I was fed up with this that I should have.
I think at this point I've got a significant amount of money invested in this project. A hugely significant amount of money.
That's disappointing.
Yeah.
I'm sorry.
I'm just glad we're finally possibly going to get it done.
So if this works, this is the ultimate. Like, you wouldn't have this machine if it weren't for doing that.
Yeah.
Would you? If there's any good part about this, that's probably it.
Well, back when we started this, my favorite size was the 17.
Yeah.
Because it was the most proportionate in size and shape.
Yes.
But after actually seeing a 20 in person, I kind of like the 20 better.
The 20 is awesome.
Sure is.
I'll just say that. The 20 is awesome. Get inside things. Oh, that's important.
What's that?
The screws that hold the motherboard in.
Yeah, it might help.
Now we're ready to test.
Did you put thermal paste on the heatsink?
I did.
It's amazing the engineering they had to come up with just to make the insides of the unit flat.
I know.
And you're closing the Wi-Fi antenna into the bottom.
It's have to be fully closed too.
Oh, I know. Trust me, I know.
And you only have to put these two screws in, so they go through the heatsink. Okay, good enough. The heatsink insides are in,
Sweet.
so it shouldn't have any problems. Let's see if it boots first. That's not good.
No, it isn't. Give it a second. It might do something.
This is the other thing they do when they decide not to work properly.
Of course.
Alright, we can either try increasing the voltage more, or changing the clock speed lower.
Let's up the voltage. I mean, what do we have to lose?
Nothing. I mean, it just seems... I don't think their settings were right.
What clock speed is it at? That can't be right.
It's hex.
Yeah, it's hex.
Just read it off to me.
Okay. Yeah, ready?
Yep.
77393 F8.
It's 2 gigahertz.
That's 2 gigahertz.
I mean, it's not like locking up though.
Hasn't locked up yet. The other day when I was filming the blue and white video, it just took a long time to post.
Yeah.
The first time after the overclock. So, I mean, we might be able to just let it sit for a second.
No, if it doesn't spin or access the drive, you can't do nothing. Yeah, it just only hangs. Alright. Let's change the voltage.
So I guess we're changing the voltage.
I'm gonna warn you, this is very much trial and error.
Oh, yeah, hold on. Oh no, we've been doing this how many years now? We started this project in, I want to say 19, 20, I mean 18? Might have been in 2018. I think it was 2018. It's been a while.
Very well could be.
All right, well, we'll tear it down and tweak the voltage. All right, so we're trying the 1.4 volt.
Yeah. Screen on?
Not yet.
I don't think it's pointing.
It's kicking on. It is on, and
It's not doing it.
yeah, it's not doing anything. So your thoughts?
It's either the CPU itself or my copy of Rupert.
So I was sitting in the bathroom, and I hear Collin yell, "I'm an idiot! I'm an idiot!" Collin, what happened here?
Somehow it slipped my mind that in order to boot OS X with an unsupported CPU installed, you have to set a specific NVRAM variable in the NVRAM RC, and I completely forgot about that. So all this testing for nothing.
All of the resistor changes and all of the clock switching and stuff.
Yeah, well, we're about to fix that now. I set it back to 1.35 volts at 2 gigahertz. So we should be optimal for testing.
Awesome.
So I need to make a flash drive for this real quick. It'll only take me a second.
Okay.
But let me just make sure it posts first. Okay, good. Okay, give me 1 second. I will be right back.
Sounds good.
Because I was like, it seems to be working so well,
Yeah, I know.
but it just won't boot OS X. And I forgot. That's why you don't do this stuff at midnight.
Yeah.
You forget stuff like this. Please. Right now we're booting off of a CD that I made with an application that I made to do this for me. I just didn't know if this optical drive worked, so yeah, it looks like it does. So let's see. Unless it's trying to boot from a hard drive.
I think it's trying to boot from the hard drive. Probably have to go into the multi.
Nope.
Oh,
Nope.
hey, that's a good sign, actually. So what's this application do?
It just sets that NVRAM variable for you. You'll see when it boots. But we're looking to be in good shape. This is the best I've seen one run at 2 gigahertz yet.
As far as you know.
As far as I know.
mean, it's
Like usually they won't even post
yeah.
at 2 gigahertz with these CPUs. So
It's a 300 megahertz overclock. That's
yeah.
it's pretty
Okay, so
significant.
this is a good sign.
Cool.
You can see it detects the CPU running at 2.0 gigahertz. So all we have to do is this. And select reboot. Now we should be in business. Yep.
It's a good sign. It's pretty quick.
Yeah.
Oh,
All right, we're in.
sweet.
Let's see what our specs are looking like here. Yes. There's our full specifications right there.
That's sweet.
So now all that's left to do is test it for stability using Geekbench or what have you, and make sure it works as intended.
Sweet.
So I'll leave that to you.
To me?
Yeah. You know how to run Geekbench.
Yeah, but
All right.
it's going to take a while for us to actually...
I think with our voltage at 1.35, we're a little bit higher than rating.
Yeah.
1.3.
Yeah.
We're a little bit over rating on clock speed, 2 gigahertz above 1.7.
Yeah.
I think we'll be good to go here. So let's open Geekbench and just see what happens.
Yeah, but you also know how I usually benchmark.
How do you usually benchmark?
I stress test it with YouTube, yeah.
Okay, we'll do that too. But for now, actually it's not in the applications folder. So as you can see, Geekbench detects the same specs as intended. So just go ahead and run the benchmarks. And usually, if it can get through this without an issue, it's pretty darn stable, in my experience. But we will test it with YouTube. I have had them run through this no problem, but fail on YouTube tests. So
yeah.
we'll test that as well. But so far, so good. We're progressing through the Geekbench. It takes about 4 to 5 minutes to complete. So we'll pick back up with you there.
It's actually going pretty quick.
Yeah, but this part goes fast. It usually gets slow towards the end.
Yeah. So guys, yeah, the Geekbench score just ran through here. We are 1128. What would that rate compare to other things?
I don't know, but I'll have to check that later. I have some other results in my Geekbench account we can compare against.
But that is, it took less than 4 minutes to complete this test. That was lightning fast. And so far, it seems really stable. It's conducting heat well through everything, and it just seems to be working totally fine. It's just freaking incredible. So, yeah, we're going to do some more stress tests on this thing, but so far, unless there's anything else that comes up, it's finally finished. And we'll do one more video on this system once I get it home, and we'll do an upgrade on it and do some real benchmarking and see how it does. But I think it was a success. What do you think?
I think so. This is, like I said, the best one I've ever done.
Yeah.
Ever seen. So
it's good. It's good.
It'll be good to go here.
Yeah, it's... I just can't believe this thing's finally finished. I think we started this project maybe in 2018.
Yes.
So, you know, it's, what, 6 years?
Yeah, about 6 years, I think.
Yeah, something like that. So it's been a long, long, long time in the making. But we may have finally gotten it to work. If there's any other results, we will update you on in this video. If there isn't, that's the end of today's video. Collin, thank you for having me.
Of course.
And thank you for finally getting this thing to work. This is incredible. So, I hope you guys enjoyed today's video over at dosdude's house, over in DOS Lab.
Yes.
Yeah, and you know, this is just, I'm speechless at this point. But yeah, it's the end of today's video, guys. Don't forget, I do have a Patreon now if you'd like to help support me. There'll be a link at the end of the video and also in the description below. And this has been a Hrutkay Mods video. See you guys. Well, I think we figured out that it is indeed stable. This is the world's fastest iMac G4, just because it's also stable. And this is awesome. So, yeah, it looks like we're good. That was even better than last night. The things you do to just have fun doing this stuff.
Yes.